Assalamualaikum. My name is Muhammad Taufik bin Zulkifli. My matrix number is CD240290. For objective in this experiment is to investigate the effect of friction on a body sliding down an inclined plane and to determine the coefficient of friction between the surface of the plane and the body. Next is additional theory. First, basic concept. When an object is placed on the inclined plane, it experiences force due to gravity, the normal reaction from the plane, and friction. Friction opposes the relative motion or tendency of motion between the object and the plane. Second, force acting on the object. There are three forces, which is weight mg, second is normal reaction force R, and frictional force F. Third, coefficient of friction. The coefficient of friction determines the ratio between the maximum frictional force and the normal force. There are two types. First, static friction. Prevent the object from sliding until a critical angle is reached. And the second is kinetic friction. Act when the object is already in motion. Fourth, condition for motion. In equilibrium, when mg sin theta less than mu r, the object remains stationary. In impeding motion, motion begins when mg sin theta equal to mu r. This corresponds the critical angle where tangent theta equal to mu. In sliding motion, when mg sin theta more mu r, the object slides and kinetic friction act. Fifth, inclination angle and friction. At angle greater than theta, the object acceleration down the incline and the acceleration is given by A equal to G sin theta minus mu cos theta. 6. Practical application. Design of road and ramps, ensuring stability and safety by maintaining slope within the critical angle. Motion of vehicle, understanding tire grip on inclined surface. Mechanical system, balancing force in system involving inclined plane. 7. Energy perspective. Work done against friction, Wf equal to Fd, where d is the distance moved along the plane. Potential energy loss, Pe equal to mgh, where h equal to t sin theta. Kinetic energy equal to 1/2 times mv square. And lastly, experimental determination of mu. Using an inclined plane, the coefficient of friction can be experimentally determined by slowly increase the angle theta until the object just begin to slide. Second, measure theta and calculate the mu equal to tangent theta.
Assalamualaikum and a very good day. My name is Muhammad Yusuf bin Arifin and my matrices number is CD240071. Now I will present about the experimental procedure. For the test one, which is find the coefficient of friction. First one is secure the mounting panel as shown in figure 5.2. Hang the plumb line over the protector center screw. Weight of the block for 3 times and record its average weight. Next, use the metal surface of the block placed in contact with the wooden surface of the plane. The third one, place the block at the right hand end of plane and tilt the plane until the block slide down the plane with uniform speeds. Next, give a block a starting push to overcome static friction. When the correct angle has been obtained, measure the angle at the protector recorded against the plumb line. The last one is record this angle, which is at the angle of friction of steel against wood. For the test 2, firstly, do not alter the angle of plane, which is now at angle of friction as shown in figure 5.3. Secondly, place the block at the left-hand end of the plane and place the cord over pulley. The third one, attach the wake hook to the end of the cord and apply wake until the block slide up the plane with slow uniform speeds. Fourthly, once again, give the block a light starting push to overcome static friction. The last one, record this wake including the wake hook of 0.1 Newton. For test 3, 4, 5, 6 and 7, repeat as for test 2 for angle of 0 degree, 10 degree, 20 degree, 30 degree and 45 degree. I will present about the data results. For the test 1, the angle of inclination of plane is a theta equal to 19 degree. Next, test 2. When an angle is a 0 degree, the applied force by experiment is 0.23 and by calculation is 0.26. When we compare, we will get 11.54%. Next, we move on to the test 3. The angle of inclination of plane is a 10 degree. The applied force by experiment is 0.4 and by calculation is 0.36 and we will get 11.11. After that, test 4. When the angle is 20 degree, the applied force by experiment is 0.58 and by calculation is 0.51. The comparison percentage of differences is 13.73. Next, test 5. The angle of inclination of plane is a 30 degree. The applied force by experiment we will get 0.68 and by calculation 0.61. The percentage of differences is 11.48. And the last one, test 6. The angle of inclination of plane is a 45 degree. The applied force by experiment is 0.81 and by calculation is 0.72. When we compare, we will get 12.5%.
Hi and Assalamualaikum. My name is Muhammad Salmi bin Kashfi. My registration number is CD240191. Today I'm going to explain the observation about this experiment. From the experiment, we start to find a coefficient of friction by the technique used in the sliding friction. Place the block at the right end of the plane and tilt the plane until the block slides down the plane with uniform speed. Give the block a starting push to overcome the static friction. When the correct angle has been obtained, measure the angle at the protractor with the aid of the plumb line. So record this angle as the angle of friction, and we found the angle of friction is 19 degrees. The coefficient of friction is equal to tan is equal to 0.32. Next, for the second test, we made the plane position at 0 degree. Attach the wake hook to the end of the cord and apply weights until the block slides up the plane with slow uniform speed. Give the block a light starting push to overcome the static friction and record the wake. After that, we continue the next test with the plane position at 10, 20, 30 and 45 degrees to find the wake that makes the block move at a uniform speed. So from the test, we can determine value of the P wake that can make the block move at uniform speed with the specific angle of the inclination of plane. So for the calculation from result, calculate the coefficient of friction by using equation 3 for test. So mu equals to sin theta over cos theta equals to tan theta. So theta is 19, so mu equals to tan 19. So we got mu equals to 0.34. So for the C, in the case of the angle of plane inclination theta equals to 0 degrees, calculate the value of the coefficient of the friction mu and the weight of block W. So formula is the same, so theta also the same. So for the W is equal to mg cos theta. Theta is 0, W equals to mg cos 0. The mass is 0.077, the G is 9.81, and the cos 0 is equal to 1, so for the total is 0.76 Newton. And D is calculate the value of P for each angle including at P at the angle of friction mu. So the formula is P equals to W sin theta plus mu W cos theta. So for the example, P1 angle of friction is 0 degrees. So we got the 0.26 Newton.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Zulfikri bin Muhammad Afandi. My metric number is AD220045, and today I want to explain my part, which is discussions. So question A, discuss the values of P obtained by experiment and calculation. Compare those values with the force S acting down the plane. The P values obtained by experiment are less than the measurement values of P. Both P values increase by experiment and measurement when the angle of inclination of the plane increase. When the angle is equal to 0, the force acting down the plane is 0. As the angle of inclination increase, P and S also increase, and P is always greater than S. Question B, suggest some reasons why there are difference between the values of P by experiment and P by calculation. The difference occur between the values of P by experiment and P by calculation due to parallax error, in which our eyes are not perpendicular with the angle of the plane. Next, instrument error, where most instruments have readings that drift over time. The amount of drift is generally not a concern, but occasionally this source of error can be significant and should be considered. And the last, systematic error, which we have to take out all load before starting the next round, is because if not, the spring that inside instruments may affect the results. So the question C, state the difference between friction on the horizontal plane and friction on the inclined plane. The difference between friction on the horizontal plane and friction on the inclined plane, which they both have frictional force acting that will be the same nature, acting in direction opposite to relative motion. But the value of forces will vary differently. This due to the frictional force is directly proportional to the normal reaction. Hence, the normal reaction in both cases will be different, so the final value of forces will be different too. Lastly, the friction on the horizontal plane does not have angle, while the friction on the inclined plane has an angle. The friction and force of an inclined plane can be defined as a function of the inclination angles and the gravity force, while the friction on the horizontal plane is not affected by the causes and is primarily determined by the external forces acting on the body.
Okay, next, I'm Muhammad Shurim, will present about questions. So for the first question is, what is the connection between the angle of friction and the coefficient of friction? To understand this relation, we should know that what is the angle of friction. This term is used for angle between the resultant force, frictional force, and normal force. Coefficient of friction is the ratio of frictional force to the normal force. So, for the relation, when the object is on the verge of sliding, the frictional force reaches its maximum value. Thus, angle of friction directly linked
to coefficient of friction through the tangent function. So for the next question, explain two engineering applications showing the significance of the friction on the inclined plane. So the first application is inclined conveyor belts that are used in industries to transport materials such as coal, minerals, or goods between different heights. Working principle for this application is friction between the belt and the material ensures that the material stays in place during movement, preventing it from slipping or rolling back. For the second application is braking system on roads. While on slopes, vehicles on roads on inclined planes require vehicles to have braking system that utilize friction to control descent. The working principle is friction between the tires and the road prevents vehicles from sliding down uncontrollably, ensuring safety. This application relies on controlling and maximizing the frictional force to ensure efficiency and safety. Here is the last part, which is the conclusion. According to the study conducted in this lab, the measurement equipment and the block and apparatus material quality are the sources of the mistakes. More testing with other apparatus and block material along with more accurate measuring tool is required to provide a more true analysis of these issues. Despite the possibility of this error, the experiment consistent trend indicate that the block surface area in contact with the surface plane has no bearing on the coefficient of friction, and the angle needed for the block to slide down the inclined plane decrease with increasing block weights. Since the result of the test did not support the idea, more research is required to demonstrate that the coefficient of friction reduces as the block climb up and incline at a greater angle. In summary, the experiment demonstrates that the friction on an inclined plane is influenced by the slope angle and the characteristic of the material touching one another. In many real-world engineering scenarios, efficiency, safety, and usefulness depends on the ability to control and manage friction.
And this is our reference. That's all from us. Thank you.